Sorry. So I repeat once again, good morning everybody. We are going to study today high frequency induction welding. So in previous classes we have covered hot gas welding process, where hot gas are used in the terms of, that is, nitrogen or inert gas or air. Then hot tool or heated tool welding process, where the metallic strip, plate, wire, roll, they are used as a hot tool. Then nuclear welding we have studied. Today we are going to see two important techniques. Out of them, one is high frequency induction welding. Now everybody know the principle of induction. So principle of induction is what? When current is passed through the primary, the heat or secondary current generates into secondary, which causes heating of that whatever object is acting as a secondary metallic object. So secondary current is generated into that metallic object. That generation of secondary current causes them to heat. Here, what is principle in high frequency induction welding? In this case, whatever secondary current is generated into the metallic part, that metallic part is in contact with the matting surface of the plastic. So this is one of the plastic surface, this is another plastic surface, and this is the metallic part is in between. So coil is around it. What will happen? Secondary will generate here inside this. It will get heated. Once it will get heated, this heat cause this surface plasticized, and then you can apply tight joint. Now here are two cases. There is one concept called as insert. You might have seen many plastic components coated with metal. Your knife you can check. So metal is inserted into the plastic handle. So these are called as inserts. Sometimes this insert remains there as it is, or after that you can remove that insert and only press the remaining plastic sheet. Now when this insert is remaining inside two mattings or in between the matting surfaces, it may cause the generation of stress. It may cause the generation of stress over it. So depends upon it. You can replace this with some another concept. So these are called as implants. What is that implant? So for example, first thing you remember, this technique is used for complicated joints. This technique is used for complicated joints. When joint is complicated, your metallic part, your coil, everything will become complicated. So in case of complicated joints, it is very difficult to place the insert metallic part between the matting surfaces. Then in that case, how it is achieved? In that case, your plastic material particles mixed with metallic powder. I repeat once again, plastic material mixed with metallic powder, and mixture is prepared, and from that mixture gasket is prepared like your washer. So shape to that gasket, it is called as an implant, is prepared according to the shape of joint. So joint design is the important concept here. When your joint is complicated, for example, this is a joint, suppose L-shaped joint. I have to join this. Okay, I want to join. So I want implant of this shape. See, same thing. So assume that there are no fingers, and see the outer line of this. So this is one complicated part. So this one complicated part joined with another same shape complicated part. Now I am going to prepare one gasket of this shape, washer-like material. So that gasket is prepared by thermoplastic of the same material as that of base metal mixed with metallic powder. Then what I will do? I will take this gasket. Now this is made up of the same thermoplastic as that of base metal, and it is having, assume that it is having same shape as that of my palm. माझ्या हातासारखा shape असे समजा त्याचा. So this is one of the thin plastic material having metallic particles in it. Having metallic particles in it. So this I will design the joint. I will give shape to it as per the joint. And now I am keeping it in between in this way. Okay. Assume that this is of same shape. And then when I will pass the current in the coil which is surrounding to this joint, what will happen? Secondary current generated into the metallic particles of this gasket. I repeat once again. Secondary current generated into the metallic particles of this gasket. These secondary current generated into metallic particles will heat that particles. That heat is taken by this plastic material of the gasket as well as matting surfaces, and then you can apply the pressure so that particle remains inside as it is, and you will get tight joint. So imagine when joint is very complicated, in that case that shape gasket is already put inside the matting surface and you have to just pass the alternative current. Because of the passing of alternative current, secondary current is generated into the particles inside the gasket called as implant. It is called as implant. And then you can produce strong joint. So this is one of the best application where you are not able to put directly metal rods or wires in between. So high frequency induction welding used for producing very complicated joints. Now one of the important thing, so hermetic tight means airtight structures. So you can produce the joint so strong that it will be airtight. It is called as hermetic tight, and high pressure seals can be obtained from this process. So strong hermetic joint, already I told, multiple joints can be welded in a single stroke. Multiple joints can be welded in a single stroke, and then welded joints can be repaired also, and rate of production is very high in this case. You can repair the welded joints and rate of production is high also. So short note, if it will be asked, it may be for 4 marks, you have to draw the schematic diagram. So first I will explain the dictate the principle, then we will draw the diagram and advantages. Write down. I will just dictate in short because some important concepts are there, may be part of MCQ or objective. So whatever notes I am uploading, you must read it carefully because MCQ questions are based on the subjective parts only. Even there is MCQ booklet. Many times the new MCQs may be asked. That's why don't just remember ki, yes, I have read all MCQs. Now I will pass in the exam. This may not happen. Okay. So you should always read books and notes provided to you, so that apart from the booklet MCQs, if new MCQs are asked, you must be ready. Electromagnetic induction field can be used. Write down. Electromagnetic induction field can be used to heat the metal grid. To heat the metal grid or any insert placed between matting thermoplastic substrate. Matting means those which are going to join each other. Thermoplastic substrate. Joint is positioned between. Position means ठेवणे व्यवस्थित. Joint is positioned between energized coil. The coil which is carrying the alternative current. Joint is placed between energized induction coil full stop, The secondary current is generated. The secondary current is generated in the metallic part. In the metallic part between the matting surfaces. Between the matting surfaces, comma, the heat of metallic part plasticizes the joint surface. Heat of metallic part plasticizes the joint surface. In case of complicated joints, electromagnetic adhesive, electromagnetic adhesive in bracket implant. In case of complicated joint, electromagnetic adhesive in bracket implant can be used. Full stop. These implants are made up of mixture of ferromagnetic metal powder and thermoplastic. Ferromagnetic metal powder and thermoplastic. Full stop. Now see how MCQs are generated here. So it helps in reducing the stresses which are generated by inserting the large metallic inserts. So this is insert. Instead of that, flat gasket is used. The stresses generated at joint will be less. Understatement. Stresses caused by large metal inserts. Stresses caused by large metal inserts are avoided by using implants. Now make star mark and write. This may be one of the MCQ. Star mark and write down. Like other welding methods, comma, induction welding less dependent on. Induction welding is less dependent on properties of plastic being welded. Properties of plastic being so many welding, almost all welding processes, what plastic you are joining, so it depends upon that properties, but induction welding is less dependent upon properties of being welded. Any type of plastic can be joined. Okay. Now, next line. The important considerations of bond quality. The important considerations of bond quality in this welding are joint design, joint design, and induction coil design. Joint design and induction coil design. It is very fast process. It is very fast process, and welds can be made in few seconds. Welds can be made in few seconds. The schematic diagram is as shown in figure. Draw this. This is a joint. Induction coil. I hope now it is visible clearly. I have put light on. So this is the induction field. This is the induction coil. Because of this induction coil, now here for your understanding, I have shown in this way implant. Actually, it may have that U shape. And U shape may be kept as it is, and it is just inserted. It will produce the secondary current. It will generate the secondary current. Okay, and then that secondary current will cause heating, and heating will cause melting of the matting surface. And here I have shown the joint. Advantages: strong hermetic tight joint can be prepared. Strong hermetic tight joint can be produced. Second, multiple joints can be welded simultaneously. Multiple joints can be welded simultaneously. Repair of weld joint is possible. Repair of weld joint is possible. And high rate of production. High rate of production. Then next, disadvantages. There is an additional cost of implant. So you have to design this. You have to prepare this implant. You have to shape it according to joint. So this is these are the additional costs. So there is an additional cost of implant preparation, joint design. That may be one of the disadvantages. Additional cost of implant, additional cost of joint design. Then preheating of implant is required. Preheating of implant is required. Then additional cost of coil design. According to the joint, coil may also require to, we may also require to change the shape of this coil and windings. So I repeat once again, cost of implant, then cost of design of implant, then cost of joint design, then cost of coil design. All these are the additional costs. Hence, these are considered as a limitations of this process. Now, this process is frequently used for welding of large irregular shaped part. I'm telling applications. Wherever large components and irregular shaped parts are there, this welding process is employed for joining such plastic structural parts which are large in size and complicated in shape. And it is used for manufacturing of processes extensively used in sealing of plastic coated metal caps with caps of plastic bottle. Means why? This is a metal. So you have seen metallic bottle and outside coating is plastic. I repeat once again, metallic part and outside coating is plastic. You have seen many such products, maybe in Milton bottles, your tiffins. Metallic coating is inside and plastic cover is outside. So such welding process is employed by using high frequency induction welding and many times joining of cross-linked polythene pipes. Okay. So wherever the joints are complicated, wherever there is a plastic coating outside the metallic parts, wherever there are complicated large size structural parts, this high frequency induction welding is used. I hope you have drawn this figure. The next process we will see infrared welding. Infrared welding. Now I'll erase this. I hope you have drawn this. You can take screenshot also. You can take screenshot also. 5-10 years back, so there were mobiles which were having facility of infrared and as well as Bluetooth. Newly launched concept was there, Bluetooth technology, 10 to 15 years back. So in old mobiles, when we have used the mobile in 2003-4, this concept of Bluetooth or transferring the data without wire was not possible. So first the concept was launched with infrared and then with Bluetooth, and then Bluetooth has taken over the infrareds, and almost every mobile company is using Bluetooth for transmitting or connecting the two devices. So infrareds are nothing but rays. These are the rays which can be used for different purposes. In this topic, what is our purpose? Whatever infra rays are coming through the source, these infra rays are applying on the matting surface, causes them to heat, causes them to reach in plasticized state. And then once you make the sheet in plasticized zone, work of infrared is over, you can joint. I repeat my statement, earlier statement once again. Any of the welding process, maybe infrared welding process, maybe high frequency induction welding process, maybe hot tool process, maybe hot gas process, method of providing heat only changes. What is method to provide the heat? Our ultimate aim is to make this matting surface plasticized, and then you are going to apply the pressure. So how to plasticize this matting surface? Depending upon it, types of welding are varied. In case of hot gas or hot air, that source of heat was hot air or hot gas. In case of heated tool metal, source of heat was the heated tool. In case of nuclear welding, source of heat was bombardment of the neutrons. In case of high frequency induction welding, source of heat was that inserts or metallic particles which are get heated because of induction field. And here source of heat is, these are infrareds. So this welding uses, it is used for usually some big tanks, pressure plastic vessels, then pipes, where the infrareds are applied on the surface of both the sides and immediately made it to join. So thermoplastics can be welded together using infrared radiation. These are some radiations of infrared are there, and these radiations are absorbed by material. And when material absorbs these infrareds, it becomes hot and surfaces reached into plasticized zone. Now, once surfaces reached into plasticized zone, you can remove the source of infrared and apply the pressure. This infrared heat transform without contact is the important concept. So I will first draw the simple line diagram and then actual diagram. So these are two surfaces. This is infrared source. This is a gap. This you are going to join. Before that, you have to insert this infrared unit, which will cause the generation of radiations, and these radiations will cause heating of these matting surfaces. Then you can take it out and then you can apply the pressure. Very simple. So infrareds are used to heat the surface. Okay. Heat input is specific, energy and efficient, and precise and controlled time and controlled infrared limits are allowed. This unit is designed in such a way that you have very precise control over the infrareds and radiations. Specific time is applied, and within that time you can apply that and take it out. This typical application of infrared, I already told, these are used for door trims, center consoles, and particularly for air pipes, fluid containers, tankers. There are big pipes, fluid container, some tanks are there, some round pipes are there. So these are the particular applications of infrared. And the main advantage of infrared is welding. So the important advantages I'm telling, ability to fast heating typically in 4 to 5 seconds. Within 4 to 5 seconds, you can start the joint, and strong joints are prepared in short period. Rate of production is very high, and high constant and low scattered mechanical properties will be observed in infrared welding. So scattering of properties is one of the important disadvantage in many welding process. So at this point, properties are very different. At this point, scattering of the properties. So this case of infrared welding, you will observe minimum scattering of the properties of the weld. And see here, main application of the components are in the aeronautical industries, where you require very crucial and precise joint. And here, as this process is very fast and it is having good flexibility, this process is used for many of such precise work and precise applications. Whatever structural reliability, so once some structure you have produced in some, whatever may be the assembly of the product you have produced, its structural reliability is more in case of infrared welding. So I repeat once again, it is very simple to understand. Infrared source is used between two matting surfaces. It is with precise time and controlled infrared radiations are applied. Once you apply it, you can produce the joint in 4 to 5 seconds. This is usually used in precise areas like aeronautical industries. Structural reliability is more than other sources. It is used usually for some of the fluid tanks, some door strips, then some other tanks and pipes usually which carries the fluid. So such applications, larger pipe I'm saying, is for infrared welding. Now how the diagram, before that you write some lines, then I will draw the actual diagram. Principle. Thermoplastic can be welded together. Thermoplastic can be welded together using infrared radiations. Using infrared radiations. These radiations are absorbed by matting surfaces. And heat is generated to plasticize it. Heat is generated to plasticize it. Next star mark, infrared heat can be transformed without contact. Infrared heat means it is directly heat source. Radiations are heated. It is heat source directly. Infrared heat is transformed without contact. The typical applications are air duct pipes, fluid containers, tanks, filters, housings, means housing of tanks and filters. The main advantage is, one by one, right? Ability to heat fast, in bracket 4 to 5 seconds. The main advantage is ability to heat fast, in bracket 4 to 5 seconds. Produce the strong joint. Then high productivity and high structural reliability. It is widely used in aeronautic industries. aeronautic industries. Schematic diagram is as shown in figure. These are two matting surfaces. This is temperature sensor. Draw this. So this is the part all about welding of the plastic. So in unit number 3, what we have covered? We have covered the classification of welding processes. It includes hot tool welding process, hot gas welding process first, then hot tool welding process, then nuclear welding process, then high frequency induction welding process, and infrared welding process. All these 4-5 processes which we have studied, there is only basic difference in changing the method of heating the plastic surface. Otherwise, it is similar to the regular welding process. Welding process is nothing but joining two parts with or without application of pressure. But here, application of pressure is compulsory. Okay, so you are changing just method of heat. When you change the method of heat, type of welding process is varied. So this is very simple and small topic. The outcome of this topic is at the end of this chapter, students will be able to select the suitable welding process for particular application. So in case of subjective questions, short note or sub questions A, B, C may be asked. In case of objective questions or MCQ questions, what are the contents wherever are dictated, I asked to make the underline, etc. And you can get maximum marks once your concept is clear. Okay, this is all about the unit number 3. Just 1 minute.